Hello, today we're going to write equations of piecewise functions. So we're going to use our handout and we're going to jump around a little bit and you're going to finish the rest. So we're going to start on number 2 on the handout. So it looks like this, and you're going to notice that this has g of x. G of x means function notation, means it passes the vertical line test. Even here on the y-axis, notice it's only going to touch that graph in one spot. This one's filled in, this one's open, so it is passing that vertical line test all the way across from left to right, which means we have a function. So we used function notation, g of x. You're also going to notice you have two pieces, and so that means we have two lines in our equation. Let's go ahead and start our first part. You're going to notice the shape of that graph. Notice it's a straight line. So you can write it using y equals mx plus b. Or you actually could use absolute values and other functions that have kind of this straight line look to it. Usually I try to go with the most basic, so I'm going to write an equation of a line, y equals mx plus b. I need m and I need b. So my m is my slope, so you can pick any points on this line and count your rise over your run. You're going up 1 and to the right 1, up 1 to the right 1. So your slope is 1 over 1 or just 1. Then we need our b value, our y-intercept. Where are we touching the y-axis? It's at -2. So to write that equation, it's y equals 1x minus 2. But we don't usually write the 1 in front of an x, so it would just be x minus 2. Now, we don't have the entire graph. Going from left to right, we have part of that graph. So that means we need to limit its domain. So to limit its domain, you look at which piece you have. And so notice you have all the piece over here on the left side, but it stops at your x value of 0. Notice you don't have anything to the right of your x value of 0. So we're wanting all our x values that are going off to the left, which means all of our x values that are less than 0. Notice also this is an open circle. Open circle means it's not included. So we don't have the equal to. It's just our x values that are less than 0. All right, let's look at that second piece. Does that second piece look familiar to you? If you had to take one of your parent functions and look at what kind of graph that looks like, what would you say? So notice it's crossing at 0, 0. It's crossing at 1, 1. It's crossing at 2, 4. That one might give it away. It's actually a piece of a parabola. So if it's a piece of a parabola, and notice the other half would have been coming up like this, it's symmetric. So we're only taking our basic shape of our parabola, x squared. So our graph is y equals x squared, but we didn't use the whole graph, we only used the right half. So where does it start? It's starting at 0 and going off to infinity. So we want our x values that are greater than 0. And if you notice, we've got a filled-in circle there. A filled-in circle tells us we also want to include that point. So we want our x values that are greater than or equal to 0. All right, that's number 2. We're going to skip on down to number 5. Notice how many pieces number 5 has. It has 4 pieces, which means we're going to have 4 lines in our function for j of x. Okay, so I'm going to tell you on this one that there's multiple answers you can have, and you'll see why here in just a second. Let's first look at this first piece. We need to know the slope of that line. We also need to know its y-intercept. So let's go ahead and count out our slope. We're going up 2, right 1, up 2, right 1, up 2, right 1. If you continue to go up 2, right 1, where are you going to cross this y-axis? Go ahead and count it out. So it looks to me like our y-intercept is going to be at 9. So if we go up 2, right 1, our slope is 2 over 1, or just 2, and our y-intercept, our b value, is 9. So we get y equals 2x plus 9. Now, we're not including the whole graph. We're just including this part of the graph. So it goes off to negative infinity, and it stops at what x value? What is this x value? Count it out. We go left 1, 2, 3. So at -3, we're wanting all the numbers smaller than -3. So everything to the left is smaller. So we want our x values less than -3. Now, at this point, you can't include it in part 1 and part 2. You can only include it in one or the other. So here's where you can have multiple answers. You may choose to include it in part 1, or you may not. So if you decide to choose to include it in part 1, you would have this top look over here. If you decide not to include it, it would look like this one. Now, let's say we don't include it on part 1, then we must include it in part 2. But if we chose to include it in part 1, then you cannot use it in part 2. You can only have that filled in circle in one part of that equation. Otherwise, it wouldn't be a function. All right, so now let's look at part 2 here. Part 2 is a horizontal line. Horizontal lines are always y equals a number. What y value are we going through? Count it. We got 3. So our equation is going to be 3, and the next part's going to vary depending on how you included this x value at -3. Notice this piece starts at -3, your x value of -3, and it goes all the way up to your x value of 0. So again, you have a couple options. You can include this value at 0 on piece 2, or you can include it on piece 3. You get to make a choice. So we're going to write if our x values are between -3 and 0. Notice I did not include it at -3 on the top one, so I must include it on the bottom one. Here I went ahead and chose to include 0 on piece 2, which means when I do piece 3, I can't include 0. All right, let's go ahead and get piece 3. So to get piece 3, notice it's another piece of a line. This time it's going down from left to right, which means I have a negative slope. Let's figure out that slope. We go down 1, right 1, down 1, right 1. So it's a -1/1, or just a -1x. What's our y-intercept? Count it out. We went up 3. So it's -x plus 3. Now remember how I said I didn't include, or I included 0 here, so I'm not allowed to include 0 there? All right, there it is. Now this piece starts at 0 and goes how far? 1, 2, 3, 4. It stops here at 4. So I can either include the 4 or not include the 4. I decided not to include it on this one, which means I must include the x value of 4 on piece 4. All right, what about that piece 4? Well, our slope, we go up 1 and right 1, 2, 3, 4. Up 1 to the right 4 is 1/4, or 1/4 x. What about that y-intercept? Well, if you go down 1 and to the left 4, it's going to touch at -2. There it is. Remember, we did not include the point at 4, so now I have to include the point at 4, and we're wanting all our x values that are greater than 4 are going off to the left. Now, remember how I said there's multiple answers? I'm only going to show you 2 of them, but there's absolutely more answers than this. So, notice my equations all stayed the same. Notice at -3 I included it on the first one, but did not include it on the second one. Notice on the second one I included 0, but did not include it in the third one. All right, on the third one I included 4, but did not include it on the last one. So it's up to you on which one you want to include it on, which gives us a variety of different answers we can choose for this j of x. Okay, so I would like you to go finish the rest of the worksheet and then check your answers on Google Classroom.